Hello, my name is Reynard Ko, and I will be presenting the first lab in Physics 2212. This is an overview of the presentation. And so first, as an introduction, this lab will be going over Coulomb's law and the idea of charge. And it will delve into how to determine the amount of atoms in a U-tape based on its excess charge. And we also will need to calculate its excess charge. And to do this, we have these three equations. We have Coulomb's law, we have force, how to determine force based on electrical field, and how to determine said electrical field. So first of all, we'll be going over the details of the experiment. And the first part is to determine whether or not the U-tape is positively charged. And in order to do this, we place a variety of different items next to the U-tape and see how it interacts. In order to determine if it is positively charged, we take something that we know is negatively charged, such as a pencil that has been rubbed on a cotton sweater, and we place it near the U-tape. And in this case, the U-tape must be positively charged because it was attracted to the negatively charged pencil. Now, the main part of the experiment, the system, it contains the two U-tapes, and the surroundings is the experimental setup, which is like the two books that we placed on the side to hold the U-tape. And now these are the measurements that we got from the experiment. And the basic gist of the experiment is we have a top U-tape and a bottom U-tape. And the bottom U-tape is slowly brought up until the top U-tape is at an equilibrium, or basically it is staying still. And these are the measurements that were taken, or the distance between the tapes is taken when the two tapes are still. And with these measurements, we can put it into this formula here, which is to find the excess charge of the U-tape. And now we can actually model this through Glowscript, and this is my code. This is the main meat and potatoes of the code, and it basically just takes the constants and measurements that we placed in or we set up in the code, and it just runs the numbers. And when we run this code, we get this. As you can see, the vectors for the two forces from gravity, which is the orange one, and the force based off the electrical field, which is the purple one, they are equal in magnitude, and this makes sense because the system is in equilibrium. Now, in order to determine the amount of atoms that we had in the U-tape, we just a simple formula. It's basically the area of the tape divided by the area of an atom. We get this number, and if you recall, it is pretty different from the value that we got from the model, and this could be due to a variety of things, and maybe possibly because of these three assumptions. And here we treat the tape as a point charge, and in reality, this is definitely not the case. The tape has a width and length, and the charges throughout the tape might not be equal throughout. We also assume that the two U-tapes that were created could have roughly the same amount of charge, and this just might not be the case because the creation of the two U-tapes might have caused it to have a different amount of charge. And additionally, air resistance, we assume that air resistance is negligible when in reality the heater or the AC in the environment might have interfered with where the top tape would stop. And here, these are some of the hypothetical questions. If the electrons and protons had switched their charges, I don't believe that this experiment would have changed very much. And the reason for this is because opposites would still attract and similar charges would still repel each other. So the basic idea of the bottom U-tape repulsing the top U-tape wouldn't have any effect. And it is important to handle the charge tapes as little as possible. This is just to ensure that excess charges don't transfer from your hand to the U tape or vice versa. And it helps keep your data as clean as possible. And yes, that is my presentation. Thank you for listening, and I hope you have a good day.